Hello students. Next, theorems on trees. Let T is graph on P vertices and Q edges. If T is acyclic, that means T is not a cyclic, and Q is equal to P minus 1, then T is connected and Q is equal to P minus 1. Second, let T is a graph on P vertices and Q edges. If T is connected and P is equal to Q minus 1, then T is connected and every edge is an isthmus. Third, let T is a graph on P vertices and Q edges. If T is connected and each edge is isthmus, then there exists exactly one path between any pair of vertices of T. Next, every tree with at least two vertices has at least two pendant vertices. Next, a connected graph G with P vertices and P minus 1 edges is tree. Next, a graph G is a tree if and only if it is minimally connected. Next, let T be a binary tree on n vertices, then show that T has n plus 1 upon 2 pendant vertices. So that means if T be a binary tree on n vertices, then T has n plus 1 upon 2 pendant vertices. So these are the theorems on the basis of trees, and also this statement important in the MCQ exam. Next point is diameter of a tree. Diameter of a tree. Definition: diameter of a tree T is defined as the length of the longest path in T, or let T is a tree whose vertex of maximum eccentricity. Eccentricity of vertex V is called diameter of tree. Notation: diameter of tree T is equal to capital D of T. That is, D of T is equal to maximum of E of V, such that E of V is eccentricity of vertex V. For this, it is also important center of a tree and radius of a tree. We know that what is meant by center of a tree and radius of a tree. Center of a tree means a vertex with minimum eccentricity is called a center of tree, and radius of a tree means the eccentricity of the center in a tree is called radius of a tree. So next example, for given graph T, find center of T, radius of T and diameter of T. This is the given graph. First we have to find the eccentricity of each vertex, then we find out center, radius and diameter of tree. First, eccentricity of V1 means maximum distance of V1 to the another vertex. So 1 2 3 1 2 3 4 5 6 1 2 3 4 5 1 2 3 4 5 6 1 2 3 4 5 6. So maximum distance of eccentricity of V1 to the another vertex means remaining vertex. So eccentricity of V1 is equal to 6. Now eccentricity of V2. eccentricity means काय, आपण V1 ची eccentricity कशी फाइंड आउट करणार. V1 चा डिस्टन्स आपण V2 V4 V3 अँड सो ऑन V10 पर्यंत चेक करणार. जे मॅक्झिमम डिस्टन्स असेल ती काय असेल V1 ची eccentricity. आता V1 चा V2 पर्यंतचा डिस्टन्स 1 आहे, V4 पर्यंतचं 2 आहे, V3 पर्यंतचं 3 अँड सो ऑन V10 V9 पर्यंत काय आहे 6 आहे. म्हणजे मॅक्झिमम डिस्टन्स काय झालं तुमचं 6 झालं. सो इसेंट्रिसिटी ऑफ V1 इज इक्वल टू 6. सिमिलरली वी फाइंड आउट इसेंट्रिसिटी ऑफ रिमेनिंग vertices. So eccentricity of V2 is equal to 5. You have to check that, eccentricity of V3 is equal to 5. Eccentricity of V4 is equal to 4. Eccentricity of V5 is equal to 3. Eccentricity of V6 is equal to 4. Eccentricity of V7 is equal to 5. Eccentricity of V8 is equal to 5. Eccentricity of V9 is equal to 6, and eccentricity of V10 is equal to 6. Now, by the definition of center of T, radius of T and diameter of T. Center of T means minimum eccentricity of all other vertices. So here minimum eccentricity is nothing but the 3. And which vertex has eccentricity 3? V5. So radius of tree is nothing but the 3 and center of tree is nothing but the V5. And diameter of tree means maximum eccentricity among the vertices. So maximum eccentricity is nothing but the 6. So diameter of tree is 6. Here, now write down. Here vertex of minimum eccentricity is V5. Therefore V5 is center of the given tree. Center of the given tree. Now center V5 has eccentricity is 3. Therefore radius of tree means R of T is equal to 3. Now maximum eccentricity from all other vertices, maximum eccentricity from all vertices occurs at V1, V9, V10 and it is 6. Therefore D of T is equal to 6. So this is the easy example how to find center of tree, radius of tree and diameter of tree. So next point, there is some example for your homeworks. Find center, radius and diameter of the following tree. This is the first tree and this is the second tree. You have to find out the center, radius and diameter of these two trees. Now next is theorem. Every tree has either one center or two adjacent vertices as a center. Means प्रत्येक ट्रीला एक सेंटर असू शकतो किंवा टू ॲडजसंट व्हर्टायसेस हे त्याचे सेंटर असू शकतात. प्रूफ. Let T be any tree having more than two vertices, more than two vertices means दोन किंवा दोन पेक्षा जास्त. Therefore T has at least two pendant vertices. We have already seen that the remark of the trees. Which remark? Just a minute. Actually, there is one remark. We have already seen that. If T has more than n vertices, then T has at least n minus 1 pendant vertices. Actually, we have seen that this remark. Just a minute, guys. Okay. T has at least two pendant vertices. Now, delete all pendant vertices from T and call the resulting graph as T1 and call the resulting graph as T1. So T1 is also tree, T1 is also tree, and eccentricity of each vertex in T1 is 1 less than that of eccentricity of corresponding vertex in T. If you don't understand this proof, then draw first T. T means tree. Let T be any tree having more than 2 vertices. 2 किंवा 2 पेक्षा जास्त असलेल्या व्हर्टेक्सचा ट्री ड्रॉ करायचा. आपण 5 व्हर्टेक्सचा ड्रॉ करू. 1 2 So this is a tree connected. Also it does not contain any cycle. Now you can see that it has at least 2 pendant vertex, means at least means 2 किंवा 2 पेक्षा जास्त. पण इथे तुम्ही बघू शकता 4 pendant vertex आहे, म्हणजे 2 पेक्षा जास्त आहेत ते. Now delete all pendant vertices from T. This is a T. Now delete all pendant vertices. So आपण ते डिलीट केले, त्यानंतर आपल्याला फक्त एकच व्हर्टेक्स भेटला आहे. अँड कॉल द रिझल्टिंग ग्राफ ॲज T1. T1 is also tree. Yes, this is a tree. And eccentricity of each vertex in T1 is 1 or less than that of eccentricity of corresponding vertex in T. 1 असू शकते, 0 पण असू शकते. आता तुम्ही ट्री असा ड्रॉ केला तर तुम्हाला काय भेटेल? ग्राफ असा भेटेल. आपण 5 व्हर्टेक्सचा ड्रॉ केला होता, आपण 6 व्हर्टेक्सचा ड्रॉ केला आणि 1 जे पेंडंट व्हर्टेक्स आहे ते डिलीट केले. पेंडंट व्हर्टेक्स कोणते आता ह्या ट्रीमध्ये? 1 2 3 4. मग आपल्याला T1 भेटला. आता ह्या व्हर्टेक्सची इसेंट्रिसिटी काय झाली? 1 झाली. आणि त्याच व्हर्टेक्सची आधीच्या ट्रीमध्ये इसेंट्रिसिटी काय होती? 2 होती. 1 2. हा आणि हा व्हर्टेक्स आहे ना, हा याची इसेंट्रिसिटी ह्या व्हर्टेक्समध्ये काय झाली? 2 आहे. सॉरी, ह्या ट्रीमध्ये काय झाली? 2 आणि ह्या ट्रीमध्ये काय झाली? 1. So in T1 is 1 less than that of eccentricity of corresponding vertex in T. Now therefore all the centers in T and T1 are same. Yes, all the centers in T and T1 are same. Again delete all pendant vertices. Again delete all pendant vertices from T1 and obtain T2 Similarly as above, center of T, T1, T2 remains unchanged. Continue this process up to remaining graph. Continue this process up to remaining graph is either K1 or K2. Hence either K1 single vertex or K2 two adjacent vertices acts as center of T. Therefore every tree has either one center or two adjacent vertices as a center. मीन्स आपण सेंटरचं जे बघितलं होतं आधीच्या व्हिडिओमध्ये, सेंटर्स कसे फाइंड आउट करायचे, आपण पेंडंट व्हर्टेक्स डिलीट करून सुद्धा सेंटर फाइंड आउट करतो, हे आपण बघितलं होतं. आता याच्यामध्ये पेंडंट व्हर्टेक्स डिलीट केले, इथे तुम्हाला ॲडजसंट व्हर्टेक्स भेटले म्हणून आपण इथं स्टॉप करणार. सो सेंटर काय झाले ह्या ग्राफचे, हे झाले, म्हणजेच ह्या ग्राफचे सेंटर सेम झालेत. सो एव्हरी ट्री हॅज आयदर वन सेंटर और टू ॲडजसंट व्हर्टायसेस ॲज अ सेंटर. सो आपण जो ट्री ड्रॉ केला त्याला काय सेंटर, टू ॲडजसंट व्हर्टायसेस, हे दोन जे दिसत आहेत ते काय ह्या ट्रीचे सेंटर. सो हिअर वी स्टॉप.